So once again, it's Boris here, doing a tier 4, and this time we have another problem for work. So, as stated the last time, work is a scalar, which is the dot product of two vectors. The vectors being one force on the object, and the other the displacement, delta D, or just a big D, depending on how you like. So, this time we're working with an incline, and when an incline is involved in force, we have force times dot product delta D, dot product cosine of the slope. So now we know that we're working with a slope. This cosine allows us to factor in any angle. So let's start working. The problem states that there's a husband and a wife pushing a toddler along. So here we have our hill here we have our here we have our toddler in a cozy little basket I've just drawn. And here is what we're measuring. The problem asks that if the husband, which I'll label as H, has to push it from a 50 from a has to push from a 58-degree angle, and the wife has to push from a 38-degree angle, how much more force does the husband need to exert if their work is equal? So let's start by balancing equations. What we have is that the force is 67 newtons. So we can write 67 delta times delta D times, this is the husband side, times cosine 58 is equal to, pens, Mr. McNeil, you need to get a new set, is equal to 67 is equal to an unknown force the wife has to exert, X, times delta D times cosine 38. So what you can see is that these two lined up. We're not concerned with the displacement, so those two just simply cancel each other out. So what we end up left with is that the husband is 67 times cosine 58 is equal to X cosine 38. So simple mathematics dictates 67 cosine 58 all over 50 cosine 38 is equal to X. After some basic mathematics, we see that the wife needs to exert 45.06 newtons of work. And in order, if you want to go in a bit more detail to find the difference, simple, 67 minus that is equal to 4,912 is the difference, is the delta diff. That's how much more the husband has to, force the husband has to put in order to do as much work as the wife. lucky him. So, with that out of the way, and hopefully work being understood by those listening, let's talk a little about efficiency. Efficiency is simple. It's how much of the work put in is actually being used. So we have the most obvious a bus, a car, if you're blind. We have a car. How efficient is it turning gas into movement this direction, into forward velocity acceleration, into a forward vector? So, efficiency, simply measured, work out, how much work is used, over the work put in. So work out would be the movement of car in a forward direction, depends on which way you think of forward, and the work in would be the combustion of the gas. Gas goes boom. That is that, but in order for it to be a percentage, we multiply it by 100, and that is efficiency. Simple, yes. Mathematically oriented, yes. But still, necessary for us to know what's happening in life. Anyways, until next time, see you.